Hello and welcome everyone to this PaaS webinar in partnership with Red Hat. Thank you for joining us today. We're thrilled to have you here for this exciting session, deploying SQL Server Availability Groups with the Red Hat Enterprise Linux High Availability add-on. Remember that this session is being recorded and that you will receive an email letting you know when the recording becomes available. My name is Eric Romero and I have a couple introductory slides before I hand over the reins to Louis and Kevin. Next, please. If you have any technical assistance, please type a request into the question pane located on the right side of your screen and someone will assist you. Please note that there will be a short evaluation at the end of the session. This will pop up on your web browser once the session ends. Your feedback is really important to us for future events, so please take a moment to complete this. Finally, don't forget to download the free technical overview, Accelerate Database Performance on-premise and in-cloud, courtesy of Red Hat. Don't forget to register to attend this year's first ever PaaS Summit Virtual PaaS Summit on November 10th to the 13th. Head over to paassummit.com to register and learn more about this year's lineup. Also, don't miss your chance to upgrade to a PaaS Pro membership and unlock exclusive benefits PaaS has to offer. And our presenters today, this session is co-presented by Louis Imershein. Louis is a principal product manager at Red Hat, responsible for driving improvements to the Red Hat product experience for SQL Server on Red Hat platforms. Louis has over 30 years of experience with operating systems and storage. He's had various roles in technical support, engineering, and product management. And our second co-presenter, Kevin Farlee. Kevin is a principal program manager at Microsoft and is responsible for driving features in the SQL Server platform, focusing on HADR for SQL Server solutions across platforms. Kevin has over 30 years in the industry in both database as well as storage management software, with roles in engineering as well as program management. And before I hand over the reins to Kevin and Louis, we have a couple polls for you. So you will see now on your screen a couple questions and a couple different possible answers to those questions. So please select the one that you relate the most. What's the main reason you're looking at SQL Server on Linux? Possible answers: where a Linux shop staff knows how to deploy to SQL Server, standardize on Linux as the cloud strategy, benefits like speed and lower cost per performance, want to run a production workloads and containers, or need a big data virtualization and an analytics platform. We're casting everyone's votes here. And let's see, a couple more seconds here for the audience to vote. Perfect. And here are the answers. This is for Louis and Kevin as well. 59% said benefits like speed and lower cost per performance. And then right after that, we got a tie between where we are a Linux shop staff who knows how to deploy a SQL Server, also standardize on Linux as the cloud strategy, and want to run production workloads and containers. And lastly, 7% of the audience says need a big data virtualization and analytics platform. Thank you everyone for voting. Now we have another quick question for you. Where are you most likely to evaluate or deploy SQL Server on Linux? Possible answers, 5 possible answers in your screen right now for you to vote and see which one do you think applies the most to you. Azure, AWS, and Cisco, UCS servers, Dell Technology Service, HPE service, or Lenovo service.
It looks like Cisco didn't go next to UCS. It's on the wrong category. So pick, yeah. So if you want Cisco, pick the second one.
Sorry for that.
That's okay.
Okay, so the results here are 32% of the audience says AWS, Azure, and Cisco. 19% Dell Technology servers, 19 as well HPE servers, and 3% Lenovo. So with that, we're gonna go with the very last one very quickly here, and then we're gonna hand it over. What workloads are you considering deploying on SQL Server on Linux? OLTP, database warehouse, data virtualization and analytics, or other? And it looks like majority of the audience is inclined for OLTP, although there is a couple there that have selected data warehouse and the other option. So we're gonna close this now. Let's see. So final results. 57% of the audience says OLTP, 17 data warehouse, and 13% there's a tie between other and data virtualization and analytics. So without further ado, thank you very much everyone for being part of the poll. Without further ado, here's Kevin and Lewis. Please take it away.
Thank you. So my name is Kevin Farlee. As was mentioned, I've been working in the SQL team for about 15 years now. You can move ahead. I'm going to give a little bit of an overview of how SQL thinks about HADR, some of the different options that you have and how they fit together, and then Lewis is going to take it from there and talk about how we do all this stuff on Red Hat. So you have a lot of different options here, starting with very simple HADR. You have VM level failover. So you can have VMs in an environment where the whole VM will fail over. That's what happens behind the scenes in cloud systems like Azure. For the basic tiers, you have storage, which is separated from the actual VM hardware. So if the VM goes down for any reason, hardware fault or operating system crashes, whatever, we'll spin up a new VM and attach it to the same disks and just reboot. So your time to come back up is basically the time it takes to reboot the operating system on the new hardware. So that gives you resilience against guest and OS level failures. And to a certain extent, assuming you have resilient disk hardware, you have that resilience as well. Backup and restore, it's mostly a DR solution. So obviously you have the option of keeping your backups in a remote site, so you have redundancy at the site level as well as the local level. VM level failure is generally going to be local within your data center. Recovery time, RTO, recovery time objective, is in the case of backup and restore going to be minutes to hours, depending on how much data you have to move and what media you're using to move that around. Small, fast OLTP databases are going to be minutes. I've seen databases in the tens of terabytes that take a long time to come back. So that's a solution that's more disaster recovery. It's not for quick coming back after a fault. It gets you back. It's your safeguard. You have your data preserved, so you're not going to lose that precious data, but you are going to suffer some outage if that's your primary strategy. VM level failover, again, is going to be less of an outage. They protect against different things. Standard HA and DR, we have failover cluster instances. Failover cluster is a technology where you have typically shared storage, and it also can be replicated storage. So you can have situations where you have multiple SANs, and there's replication even between sites at the storage level. So the disks are replicated, or you share the disks. So the classic shared disk architecture, you would have one volume which is physically mounted to both machines. At failover time, the machine that has either gone down or is being asked to give up the workload will unmount the disk, release its locks on the hardware. The other machine will mount the same hardware and spin it up, and then we spin up the application. So with VM level failure, you're starting with machine startup. Failover cluster, the system is up and running, but you're just starting up SQL, and you have the same content, so you don't lose any data, obviously, because it's absolutely the same data between them. Availability groups, I'll get into that a little bit more, but at a high level, availability groups is a SQL technology where we replicate at the database scope. So instead of replicating the whole server, we're replicating a database or a set of databases. The replication is at the transaction log level. So we take updates to the transaction log, which are made as updates happen and as commits happen, they get written to the local transaction log. At the same time, we write them to the local log. We also write them over the network to the remote node. So it has, and it's persisted directly into its transaction log, and it's hardened there. At that point, we know we're not going to lose anything. And then the secondary nodes are constantly replaying those transactions to keep the database in sync with the primary. Basic availability groups is the first tier of availability groups. It's designed to match the technology of the older, or the surface area of the older database mirroring technology. So you're limited to 2 replicas. The secondary is just passive. There's no way to access the data on the secondary. But it has all the same characteristics of the availability groups. Log shipping is another technology. It's more of a warm DR standby. What log shipping is a set of orchestrated jobs which are continually or on a schedule doing backups of the primary, transaction log backups, and then shipping the backup files over to the secondary, and then restoring those log backups onto the secondary. So it's a very coarse, granular version of what availability groups does continuously. So again, it's just doing backups and restores, and it's orchestrated with some agent jobs, which make all that stuff happen. Okay. Mission critical HADR, that's where you put your corporate jewels, as it were. So this is where you can't really tolerate any substantial downtime. And always on availability groups is one of the primary technologies we use for that. So full availability groups, it's database level protection. So each database on the primary is paired with the same database on replicas. You can have up to 8 replicas, and they can either be local or remote. RTO is going to be seconds to minutes at most. So taking the spectrum from VM failover, you're restarting the whole operating system. So the whole system is coming up, and then you start SQL, and then you start the databases. Failover cluster, the systems are up the whole time. You're just restarting SQL as the storage moves over. Availability groups, SQL is already up and running on both the primary and the secondaries, and a failover is just bringing the database online, so it's much faster. So you're just doing replay on the log and you're online. So it's much faster. You also have access to the secondaries in read mode, so you can do read and write to the primary, you can do read access to your secondaries, and that allows you to offload reporting workloads or any query-only workload. So there are some systems that it's just simpler to send everything to the primary, and that's fine. There's other systems where they have a fairly heavy read access, and you really want to take that away from your primary so you don't slow it down. And so in those cases, they'll route all the query traffic to the secondaries, and the updates go to the primary. And finally, distributed availability groups. It's a loosely coupled set of, so it's an availability group whose members are themselves availability groups, and it's designed for wide area networks, so coast to coast sort of DR scenarios. And the reason that's significant is that there's no common cluster infrastructure. Availability groups relies on a cluster infrastructure, and Pacemaker or similar cluster infrastructures to handle quorum management and those sorts of orchestration tasks. Each of the member availability groups has cluster infrastructure, but the distributed availability group does not. And the reason for that is if you have some nodes on the East Coast and some nodes on the West Coast, every once in a while the network's going to hiccup in between. And what we were finding if you tried to stretch a single cluster from coast to coast is every time you got network hiccups like that, one side or the other would lose quorum and go down. And that's unnecessary, and that causes disruptions. So you have the distributed availability groups now handles all the replication tasks automatically, and the failovers are done manually under your control. And that gives you protection from, like I say, the interruptions based on the network interruptions. Okay. So the two primary HADR technologies that SQL Server customers deploy are failover cluster instances and availability groups. And so failover cluster instances protect servers, availability groups protect groups of databases. So the idea there is that you have a set of databases that are expected to work together. So an application may need to talk to more than one database. So you want them all to move as a unit. If one of those databases moved, then your application would be stranded because it wouldn't have all the databases in either place. So when you do a failover and availability group, all the databases in that group move over. There may be other availability groups on the same set of servers, and they'll move independently. So each availability group can move independently. You can even set it up so that you intentionally have, in normal operations, one availability group active on server A and another on server B so that you're spreading the load between those servers. Failover cluster instances, it's a server level failover as we discussed. So you have some kind of shared or replicated storage. It can be SAN storage, it can be SMB file shares. You can have replication, either disk to disk replication, SAS disk keeper, something like that, or you can have SAN level replication. So from site to site, you can have, I've seen a lot of implementations where people have dark fiber from site to site, and the SANs are doing storage level replication. So from SQL's standpoint, if you do a failover, it looks like it's the same disks, it's just replicated. So again, you're moving the SQL instance from server to server. And failover is going to take typically minutes because you're bringing SQL up from nothing. So you're starting up from zero. You can have multi-node clustering, so you can have multiple nodes in the cluster. And the secondary nodes are passive because they don't have access to the storage. So only one node is going to have access to the storage. Obviously, you're not going to be able to do database operations on the node that isn't connected. Availability groups, it's a multi-database failover instead of the whole server. One of the subtleties that isn't obvious on the surface is that there's a lot of configuration information and data that is held in the system databases. Those aren't part of the availability group. So logins, users, permissions, stored procedures, agent jobs, scheduled jobs, all of that are held in the system databases and have to be kept in sync manually. Whereas failover cluster, all of that moves with the instance as it moves from site to site. Availability groups each have a full copy of the data, and it's typically either direct attached storage or some fairly fast local storage. It can be inside the box, can be local SAN or whatever technology you're using. Failover is going to take seconds instead of minutes because again, you're just bringing those specific databases online, and the time is going to depend on how active the databases were in terms of updates. So you have to roll back partial updates and roll forward updates that hadn't made it into disk. You can have up to 8 secondaries for an availability group, and the secondaries can be active, meaning that you can have read traffic, as I discussed a little bit earlier. So you can make use of those secondaries as opposed to having them be purely passive. You just can't have a write-write situation in availability groups today. Okay. So just kind of taking a tour of availability groups for HA and DR. You have your primary site, your DR site. So in this example, you have one Linux cluster. So the whole availability group is managed by a single cluster. In this case, Pacemaker. You have two nodes on the primary site, so you have fast failover between those in normal operations. That can be either because a node goes down, or if you're doing updates, upgrades of the software, you do a rolling upgrade where you upgrade the secondary and then fail over to it. And that way you're never suffering any significant downtime during upgrade operations. And then you have your DR site, which is kept online for cases where you have a site outage or network outage for connectivity to the site, whatever it is that takes down most of the primary site, so that both node 1 and 2 would be unavailable to you. Okay? So availability groups can do their replication in synchronous or asynchronous modes. In synchronous mode, the updates are done synchronously, meaning that, as I mentioned, when we do updates and write a commit record, that's written locally to the local transaction log on storage, and the commit isn't finished until we get acknowledgement that write was hardened. In synchronous mode, we also hold up the acknowledgement of that commit until we have confirmation that the write of that commit record was hardened in the transaction log and the synchronous secondaries. So we'll hold up for that. That way we know that if you have received a confirmation of commit in a synchronous availability group, we know that all of the secondary nodes in synchronous mode have that data and you won't lose it, no matter what happens. For sites that have significant distance between them, so you're talking about higher latency over the network, you may want to run in asynchronous mode, in which case we ship the updates in the same way. So we do the writes to the local log and to the remote nodes at the same time. It's all one write. But in the asynchronous mode, we don't wait for acknowledgement that it's been hardened in the remote log before we move on. That allows us to not be held up by that latency. So if you're going to wait a long time for those nodes to come back, then you don't want to be slowing down your primary workload. You already have it persisted in the local synchronous secondary, so you've got that assurance. So that's the difference between synchronous and asynchronous, and why you would use one or the other. Okay. So go through a few scenarios and what kind of topologies we'd set up to accomplish those. So one scenario is an enterprise is building out a mission critical application. So this is a greenfield, brand new application coming up. It's all Linux infrastructure. You want to have application level protections. You want your application and anything it depends on to be protected. Automatic and within seconds failover during unplanned outages. So something happens that you weren't planning for, you want it within seconds to be back online. No or extremely little downtime during planned maintenance. So again, the situation where you're applying patches, you're doing updates, you shouldn't take extended outages for that. The application is perf sensitive, and for compliance reasons, you have DR requirements. You have to be able to guarantee that even if the whole site goes down, you still have access to your application and your data. Okay. So one solution is an HADR with always-on availability groups with Linux. So you have Linux clustering. Here you have a single cluster from covering the wide area. So you have local replicas that are running in synchronous mode. One of the secondaries may be doing the backup, so that way you offload the backup traffic again from your primary. And then you have a secondary and a remote site that is doing asynchronous log replication. So you're not going to take the latency hit for waiting for those bits to go all that distance and come back, the acknowledgement to come back. But that DR site is still available for read access. So you can be doing your reporting or other read processing on that DR site, as well as you can the other local secondaries, whether they're sync or async. Okay. So another customer scenario, which I dealt with this customer, is a SaaS, software as a service application. So this was a forum system. So you have a discussion forum. In that case, you have a catalog database with a very high volume of concurrent read-only transactions. Okay, move. So in that case, you have a primary, this is what's called read scale availability group. So this is an availability group with no cluster infrastructure at all. And there's no failover possible because you have no orchestration to do that. But what it allows is for you to have multiple readable secondaries kept in sync with your primary. And so the way this worked for this forum system, if you think about it, interacting with a forum system, 90-some% of your interactions are going to be read-only because you're just reading posts. And once in a while, you're going to post something. So the way they do this, it was actually much wider geographically spread than this indicates, but users would be routed to the secondary, which was geographically closest to their network connection. So they have the best response, and it also spread the load out among the secondaries. And then when someone made a post, that write traffic got routed to the primary. So the post would go to the primary and then be replicated out to all the secondaries, while the secondaries were serving out all the read traffic for all the users that are reading posts. So that was a nice solution for those problems. Next. So in this scenario, you have an ISV with a solution that's built on SQL Server on Windows, so a legacy application that's been out on SQL on Windows for a long time. The enterprise has started moving to Linux. They've certified their applications on Linux, and so they want to move to an all Linux infrastructure for cost or whatever reasons. You guys enumerated some of them in the poll. So you have rigorous business requirements. So the solution is to set up a distributed availability group. So you have one availability group on the Windows side, which is your original, that originally was your infrastructure. It's those two Windows nodes on your right, having synchronous replication. You set up a similar infrastructure on Linux with Linux clustering and seed it with the data from the primary, the existing set of databases, and set that up as a distributed availability group between the Windows and the Linux clusters. And when you set up, so you add a second availability group, you can set it up to be auto-seeded, which means that we will automatically back up the databases on the primary and ship them over the same link that we use for the log traffic into the secondary, so you don't even have to do the backup and restore. It just automatically flows the initial population of the data from the primary to the secondary, and then that in turn gets fanned out among any replicas on the secondary site. So that's all seamless, done for you. You end up with the exact same content being kept in site on the Linux side. When you're ready to switch your operations over to the Linux side, you can just move the update traffic to point to the Linux clusters. You can reverse the flow in the distributed availability group to keep the legacy systems in sync, just as a fallback while you're making sure everything's solid. And then when you're convinced that that's a solid solution, you can retire the Windows and go exclusively on the Linux clustering side. So that's how that would work. It's a very smooth system for migration between platforms, because the data being migrated is just in the format of the databases, which is platform agnostic. You can go from platform to platform with no problem. Marketing likes to make a big deal of having mixed operating system availability groups, but that's not something that I would find useful in practice, but this is a solution scenario that would make a lot of sense. Okay. And from here, I'll hand it over to Lewis.
Thanks, Kevin. So I'm going to go through and talk a bit about the Red Hat High Availability add-on, which is an implementation of Pacemaker that Kevin was discussing Pacemaker earlier. And after I do that, we'll run through a demo and we'll set up an availability group. I've actually created some scripts that I'll share with you that are being maintained by.
Hi, Louis. Sorry to interrupt you. It seems like we lost your audio there.
Is that any better?
Yeah. Yes.
Yes.
That's better. Perfect. Thank you.
Hello?
Yes,
Yep.
That's good.
Test.
We can hear you. Can you hear us?
Hello? Hello?
Yes, we can hear you now, Louis.
Can you hear me now?
Yes.
All right, very good.
Sorry
about that. I'm not sure where we lost the audio, so we'll give it a go here.
Yeah, just right at the beginning, like
Okay.
a couple seconds after the beginning.
So I'm going to cover the Red Hat High Availability add-on, which is essentially Red Hat's implementation of Pacemaker. It is an add-on, so that means it does, you do have to have that in order to be able to take advantage of Pacemaker functionality on Red Hat Enterprise Linux. I'll give you an overview of that, and then we'll run through a demo. So in terms of the Red Hat, of the RHEL HA, there's some basic goals that we're trying to achieve with this. First and foremost is, I'm sorry about that, having technical difficulties here, is that we're trying to provide continuous availability for services and resources, of course. But we're also trying, we also need to be able to recover if there's a failure, and that failure could be in software or hardware. We need to allow complex rules for how those resources get run. We call those constraints. And we need to know what to do during a failover, and that's fencing. So shutting off servers that may have problems. At the end of the day, though, what we're really doing is just starting, stopping, and monitoring resources. And the whole architecture of RHEL HA can be simplified into PCS, which is the tool that you use to manage the RHEL HA clusters, resource agents, fencing agents, Pacemaker itself, and then CoroSync and ChronosNet. We'll walk through each of those here from an architecture standpoint. So PCS is a command line config utility for RHEL HA. All the configuration should be done through the PCS command. You shouldn't be going around PCS or you'll run into issues. It interfaces with Pacemaker and CoroSync config files and command line utilities. There's also a web-based version, which is PCSD, and this is the graphical user front end that allows for remote configuration, and I'll demonstrate this later. This runs by default on port 2224 when it's active. Pacemaker itself is the brains of the cluster, and that's why, when people refer to Linux clustering, they usually mention Pacemaker. And really, it has three things that it does. It manages the CIB, which is the XML representation of cluster configuration. So basically a flat file that has a database in it. You can think of it that way. That is, XML structured and has a layout of the configuration of the cluster and all of the options in use. It determines when the resources should be started, stopped, or monitored, and it determines when a node should be fenced. Now, CoroSync and ChronosNet, CoroSync is a low-level communication library for the clustering, and it takes care of the node-to-node communication and encryption. It handles the heartbeats between the nodes and makes sure they're up or down. And then it manages whether the nodes are in or out of the cluster. There's also ChronosNet, which is introduced with RHEL 8, which is a network abstraction layer that allows multiple networks to interconnect. So This can be extremely useful, for example, if you're in one of these remote configurations that Kevin was describing, and you need to make sure that the other network is up or the other node is up. If one of those networks goes down, potentially the the node that's on that network will be fenced. It should be. So you don't want that to happen. So one way to deal with that is to use multiple network providers, have multiple networks, and or even just use different trunks from your provider, and basically use those networks for your interconnect. Now that's a sophisticated configuration that's obviously intended for very high availability, but it is available in RHEL 8 to you. Resource agents are the scripts or programs that start, stop, and monitor cluster services. So Microsoft obviously provides a resource agent for SQL Server, but Red Hat provides a lot of other resource agents that you may find useful. For example, for Apache Web Service, you will be using one of them today. We're going to use the IP address resource agent, and we'll use that for IP failover and IP virtualization. Red Hat also provides an API, so you can write your own scripts. And then there are two special types of resource agents that you have to keep in mind. Clones are the resource agents that are managing active resources. They're all the same. Promotable clones allow only one resource to be in a different state. So with SQL Server, where we have a primary and multiple secondaries, we're looking at a resource agent that implements promotable clones. Constraints control when a resource is allowed to run. And you can think of three different varieties of constraint. Co-location guarantees the resources run on the same or makes sure that it's run on a different node. Ordering requires a resource to start before another resource. And location requires a resource to be running on a specific node or group of nodes. Now there's also a shortcut that you can use called groups. And groups allow you to require all resources in a group. So you just refer to the group, and they'll be started in the order in which they're created. So in the group. So that gives you the ordering. Fencing agents are the thing that often confuse people with RHEL HA clusters. And quite simply, there are just a lot of types of fence agents, and knowing which ones to use can often be confusing. So you can physically remove power from a device, and that can do fencing. You can force the device to restart. You can power off virtual devices. So this is what's done in Azure, for example. You can shut off access to storage. So you can use SCSI fencing, or you can just use a hardware watchdog. And if you are on bare metal hardware, or you are in Red Hat virtualization, those hardware watchdogs are a great option because they will automatically cause a system to restart if it loses touch with the cluster. So basically, after a certain amount of period, if the system doesn't hear from the cluster, that node will automatically be restarted because the hardware watchdog will not have been refreshed, and that is done in hardware by the managed on the motherboard. So why do we need fencing, and why is it mandatory? It actually is mandatory for Red Hat support. The biggest reason is that you need to have the nodes in a known state so that they can be recovered. But another reason is if you have failed nodes, you want to be sure they're in as clean a state as possible for when they come back online. So both of these are critical factors in supporting, high availability environments with a high degree of accuracy. So how do we make all this work together? Well, this is the fun part. I have to tell you, I've been working on this demo for about 6 months. That's about the longest demo I've ever developed. But honestly, I hope that you find it helpful. I know that we've already solved a lot of problems for our own consultants and SAs with this tool set. So we basically have created a community maintained availability group set of scripts. And those scripts called AG setup, I'll show you how to get them off GitHub. they really simplify setting up a SQL availability group on RHEL. We also will use in our demo today SQL Server Management Studio, and we'll use PCSD, which I already mentioned is the web-based tool for managing RHEL HA. So we're going to walk through this demo, and I'm going to take you through some of the steps involved. So the very first thing that we're going to do is we're going to set up a host equivalence between our different hosts for root that are in the cluster. And we'll do that using the SSH keygen utility and the SSH copy utility. One creates the key and one copies it around. What you need to know is that once this is set up, in each root account, there will be a .ssh directory. The content, if you want to clear out host equivalents after you've run the scripts, you should remove the contents of that directory. If you're already using SSH for other reasons, you may have other schemes that you're using for managing SSH. I trust you there, but you know, it's if you want this equivalence is basically a way to have passwordless SSH connectivity between multiple systems, and it's useful for when you're configuring a group of systems and want to get it all done at once. We also have Ansible, which has other built-in ways for dealing with this problem. And I will mention that while these scripts are shell scripts, we are working on an Ansible version of this tooling, and that'll be available in the future. So the first file we're going to look at will be params.sh, which allows you to specify the node names, the replica types, the virtual addresses, the passwords and keys you're going to use in your cluster. The second tool will be a software install. I'm actually not going to run that today because I'm sitting behind my DMZ, and but I have run it before we did the demo. And then we will generate keys that will be used to encrypt and decrypt the transports that are used but for SQL replication. We'll go ahead and run the AG setup utility, which will do all of the things that you can do in SQL Server Management Studio in terms of joining the database to an availability group and replicating it. And then we will actually configure the Red Hat High Availability add-on, and we'll set up fencing for that add-on. So our general setup today is going to be a primary node, a synchronous replica, and what's known as a config-only replica. That third node will be a node that is running a SQL Express. This is a configuration that you can actually do with SQL Server Standard Edition. You don't need Enterprise Edition to do this. And I think it was mentioned earlier by Kevin. That third node can be used to run an application, and that application could be configured to fail over onto SQL 2 as well as SQL Server can. So that's a configuration that we see, a smallish configuration that we often see. We're going to be using, of course, the SQL Server Resource Agent today. We'll call that AG cluster. We'll be using the IPadder2 resource today, which will be our floating virtual IP address for the active node, and we'll call that virtual IP. We'll be setting up some co-location constraints. So virtual IP will always run with the AG cluster master node. And then we'll also have ordering constraints. So AG cluster will always start first, and then virtual IP will start afterward. And finally, we'll be using SBD for our fencing. And again, we'll be using only the watchdog portion of SBD. So with that, let's go into our demo. I just want to check that everyone can hear me. Eric, can you confirm that you've got audio? I can hear people, but I'm hoping they can hear me because we had a sound problem earlier.
We can hear you.
All right, very good, Kevin. All right, so I'm going to go ahead and log in to SQL 1. Oh, that's SQL 2. Let's do SQL 1. And if you look here, I said I was going to set up my key generation, so we'll do that. I don't know why this is not. Should be remembering that I have done SSH keygen before. Here we go. Oh, because I know why that is. It's because I need to be root, because I'm setting up equivalents for my root users. Here we go. Sorry about that. Okay, I already actually have this set up, but I will go ahead and redo it for you. We will not set a passphrase because we don't want to have to type in passwords each time. So, and now we're going to do a copy, SSH copy ID, which will bring the keys over to the different servers. I'm actually going to do something interesting here, which is I am going to allow myself to connect to my own server, which is something that you're normally not allowed to do. But this actually simplifies my scripts so that I can do things in the same way on all systems. And then we'll go ahead and run this on 3. Here we go. All right, so now we're set up. Now I've got my file here, which I downloaded from GitHub. And we'll go ahead and extract it. Don't know what I'm having. I see. There we go. Why is this not? Okay. So I should be able to extract this file. I don't know why it's not extracting. Huh. I see what's going on. I have entered my commands wrong. And this is the trick with Linux, right? There we go. So I used a C, which says create, instead of a Z, which says unencrypt. So now I'm going to go ahead and move in here. We got to go into setup. And we're going to take a look at that params.sh file I mentioned before. You can see what I talked about. The SQL Server 1 is set up as the primary server we're doing configuration on. Our secondary for synchronous will be SQL Server 2. You'll see I do support asynchronous servers, which Kevin was talking about. And SQL 3 is going to be a config-only server. There's passwords set in here, so this file should be kept secured if you're going to use this tool, or taken off the system and then restore, however you want to secure the data that's in the file. This is the SA password for the SQL Server, which I have already installed. The listener port that replication will go over, the port that SQL Server will run on. A lot of these are the same parameters that you'd be asked for if you were using SQL Server Management Studio to configure a SQL Server. There is, however, a cluster password, which will be set by this tool for Pacemaker. There's the virtual IP address, which I mentioned before. And there are master and private keys that are used for the SQL Server replication. These keys can easily be generated with tools like MakePassword that are available on Linux. And that's a good way to randomly generate passwords. Just make sure some of the SQL configurations don't like non-ASCII characters. So you probably want to make sure that you're using a safe character set there. And the other things in here, there is a password that is used for the SQL Server account, which will be internal to, this will be for Pacemaker's account in SQL Server, and that is used by the resource agent. So the resource agent has to be able to log into that account and get information out of SQL Server, and also control SQL Server in order to manage automated failover. And then lastly, you'll see my fencing type is bare metal. And for bare metal fencing, we are using, we will be using the watchdog mechanism, or SBD. So at that point, we can go ahead and run this setup. I'm going to use a command called all setup. And what this is doing is basically just running the others. You'll see I commented out the source install. So Let's just go ahead and run this. You'll see, just as with a SQL Server Management Studio setup, I'm copying in my certificates. After having set up the master certificate, I enable HADR on my SQL servers because it's not enabled by default. I then have to restart each SQL server so that that is activated. And I am opening up the ports in my firewall. You can see they've already been enabled. So, so this allows the replication to travel. And at this point, we're going to go ahead and create the availability group, and we add on the primary, and then we join the secondary, and we will also join the configuration only server. After that, we get to backing up the database, which is already configured on my primary system. In this case, I'm using AdventuresWorks. And we will then add that database to the availability group and give it a little time to replicate out to the group. So the core SQL Server configuration is basically done at this point. We're going to do a check to make sure that the database made it over to the replicas. But all of the bits that you would do in SQL Server Management Studio are already done. And now we're getting to configuring Pacemaker. We're setting up that HA cluster ID that I talked about. We are going ahead and setting up the logins for Pacemaker on the system, as well as in SQL Server itself. We're setting up all of the constraints that we talked about for the resources, configuring those resources. Here you can see. And at this point, we will go ahead and set up SBD for our watchdog fencing and restart the cluster. Okay, so now we have a cluster, and that cluster is standing up as we are paying attention. Let's go ahead and pop into SQL Server Management Studio. And we will take a look at the cluster itself. Okay, it's going to want me to log in. Now I am logging in to SQL.ag1. SQL.ag1 is actually my virtual, is in my DNS for my virtual IP address. So this is the floating address that I'm actually logging into now. And we will go ahead and load a SQL query and run it. And this will give us some interesting information. So we'll go ahead and execute this. You can see we are up, and our SQL server that we are actually running on is SQL 1. Okay. Now we're going to go ahead and show you PCSD. So just give me a second here. And as I mentioned before, PCSD is running on SQL. We'll do the same thing. We'll go ahead and use the, we'll go ahead and use the virtual IP address. Okay. Now I have already configured I've already added my username to the HA user account. Actually, we can take a look at that. So my username is Imershein. You can see I am in the HA client account, and that will allow me to have access to PCSD through my normal login and password. So we will go ahead and log in here. Hey, look, there's no cluster. What's wrong? Well, the issue is that PCSD is able to manage multiple clusters, and so it doesn't go out and look for any specific cluster, even if it happens to be running on the same server. So you actually have to tell it about a node on a cluster, and then it will show you the information about that cluster. It's not ideal, I know, but it just is a thing about PCSD. So at this point, here's our cluster. We're going to go ahead and take a look at the internals of the cluster. We'll see, as we know already, that the virtual IP address is running on node 1. And node 2 is only running the AG cluster. Obviously, it's running a non-active version of that resource agent. And then same for SQL 3. Now you'll recall that SQL 3 was actually a configuration only replica, but you can see that Pacemaker doesn't know about that. That is all handled by the resource agent. And I'm going to show you a trick that actually can make failovers faster by actually telling Pacemaker to never fail over to SQL 3. So we'll actually see that as an example here shortly. But first, let's go ahead and look at some of those constraints we were talking about before. So ordering preferences, you can see that the virtual IP starts after the AG cluster clone promotes. And also the virtual IP and is run together with the AG cluster clone, which is, again, the primary instance. You'll also notice that this particular AG cluster clone is a promotable resource, and that means basically that you can set it to active or to a second state. I also wanted to show you the fencing. So really quickly, if we look here, you can see that SBD is configured. Even though it shows you there are no fence devices in the cluster, you actually do have SBD fencing configured. And with that, the last thing I promised to show you was how to speed up the system. And the way that you do that is by entering in SQL AG1 and SQL AG2 into the resource location preferences. I'm going to give each one an equal score so that you can fail over to either one. It won't have preference for one or the other. We'll just use 50 here. And I notice I did SQL 1 first. If I did SQL 2 first, that would force a failover to SQL 2. Okay, so we'll go ahead and do this. All right, now we're configured. And now let's just go ahead and watch a failover. So I'm bringing down SQL 1. Okay, SQL 1 is now stopped. And we'll go ahead and we will see that happen here. We'll see a change in the impact or in the configuration. It will make me relog in, of course, because this situation is, now we're failing over and we'll be on a new node, and the application is not itself maintaining passwords. So here we go. While that's happening, let's go ahead and there, you see we're already on SQL 2 here, and I can log in here to the new node. And all right, there we go. You can see we've got a cluster with a down node. All right, that's going to conclude my demo for today. And at this point, I wanted to open things up to questions.
Awesome. Thank you very much for that, Louis and Kevin. While we wait for our audience to type in any questions they may have, I did want to remind you that right after the webinar ends, we'll have a short evaluation for you to complete. That will be really helpful for you guys to complete. I also wanted to point out for you to download the technology overview that provided by Red Hat. You can download it right now from our handout section or follow the link in your screen. Now we do have a quick question here. Is there a way to automatically fail over to a remote site on Linux?
Yeah, so one of the things you want to look at with distributed availability groups is a tool called Booth. And Booth can actually, you can actually use Booth without distributed availability groups. You can use it if you're using storage replication and have just replicated the data of the cluster over another system. but Booth is designed to take two pacemaker clusters and automatically fail between them using two or more, or using a third site, or even more than 3 sites, so that you have an external site that can be watching the 2 sites and making sure they're connected to each other. So I recommend that you look at the Booth utility for that. Any other questions?
I don't see any coming through just yet, but if you wanted to go into the next slide, just for everyone to see the resources that we have available, there you go.
So if you look here, the we're providing the documentation link from Microsoft, which is actually pretty good. But as you'll see, if you look at the scripts that I provided, they are rather extensive. There is Red Hat documentation also on configuring and managing high availability clusters. If you're going to do anything very sophisticated with cluster configuration, I highly recommend that if you have a Red Hat technical account manager, they be engaged with you. And certainly Red Hat Consulting is very experienced in helping customers set up clustering environments. And then the sample scripts that I've created, which are perfect for, even pretty sophisticated clusters. Those scripts are in GitHub, and we are accepting pull requests. So I know a lot of you may be more experts on the SQL side than I am, and I'd love to see your contributions. But these scripts do work today. We do have customers using them, and certainly feel free to check them out.
So we have a couple questions now coming through. We have
Great.
this one: what happens in case of synchronous replication and secondary is not available? Do the replication switches to the async temporary, or does the primary workload remains blocked until the situation is back to normal?
So if you're in synchronous mode and the secondary is completely offline, we'll recognize that, and the workload will go on the primary. If the secondary comes up, we'll catch it up. But we're not going to take your primary offline just because the secondary is down.
Perfect.
And there's no auto failover to an asynchronous replica from what I've seen. Isn't that right, Kevin? Yeah.
Correct.
Now I have another question here.
That actually brings up a point, which is in Pacemaker, if you want to speed up your failover again, you actually can say, Pacemaker, don't even treat that third node as someplace we're going to, use a location preference and lock it down to only failing over on the synchronous nodes. So that makes a lot of sense.
Perfect, thank you. Just a quick side note, there's a couple people asking for the GitHub links. So if you go into the handout section, you can download Lewis's and Kevin's presentation, and you will be able to get the link from there. Now, does AG on Linux with Red Hat provides online rollout upgrade scenario when we need to migrate from 7 to 8, for example? Let me just read that again. Does AG on Linux with Red Hat provides online rollout upgrade scenario when we need to migrate RHEL from 7 to 8, for example? Or do we have to migrate between 2 different clusters in different versions? Does RHEL support multi-site setup with SQL AO?
So you do need to migrate the data because clustering is different between, clustering in particular is different between RHEL 7 and RHEL 8. For example, you'll notice we added ChronosNet. There's differences in the layout of the CIB. And in general, this is no different from any other database migration between a major release of an operating system. For minor releases, of course, everything just works in place. But for a major release, you would typically use a read scale availability group that we were talking about, and you would replicate the data onto RHEL 8 systems and configure a cluster there.
Perfect. We have another one here. Would you have any company running SQL AG with Pacemaker in production?
Yes, Red Hat has over 1,500 customers currently with SQL Server installed in their environments, and several of those customers are in production, including large customers in the financial sector, and energy, and healthcare, and government. A lot of government customers.
Oh, that's good to hear. Another question here from Jeff. Is there any sort of options available from Linux where we can set up in sandbox type environment for learning or training purposes?
Of course, and in fact, you know, there is a developer program for Red Hat Enterprise Linux, and that program is free. So you can then download Red Hat Enterprise Linux and get free copies of Red Hat Enterprise Linux to work with. And that should also give you access to the, you know, to everything that you need to be able to go ahead and evaluate this.
That's similar to SQL Developer Edition, which is all the surface area of enterprise, but the licensing prohibits production use. So anything but production you can do with it.
Mm-hmm.
Perfect. So I don't think there's any more questions. There is a quick comment here. They would like to see a session in the future about SQL patching in high availability on Linux. So they wanted to share that with you. And I think we have reached all the questions, unless anyone else has a quick question. We have a minute or two here to spare. Again, let me remind you, you can download the slides where you can find all these links in the handout section as well for the technology brief that you'll find in there. Remember, we'll be posting the session recording in a couple of days, so just be look out for that email in your inbox. Well, I think that is all. Thank you so much, Louis and Kevin. We really appreciate
you, Eric.
Coming present here. And thank you all for attending. Please don't forget to fill out the session evaluation, and we'll see you in the next one. Thank you so much. Have an excellent day.
Thank you.
Thank you.